everyone, this is Natasha from the Nextwork team, and today we are doing day 3 of the DevOps AI challenge, and I'm so excited to be working on, here we go, drum roll, on the project called Deploy a RAG API to Kubernetes. So if you have done the first 2 projects of the series, by now we have created a RAG API, and second of all, we've containerized that API using Docker. So this project is the third one. It jumps straight into where the second one left off, and we're now going to deploy that containerized API using Kubernetes. So if you haven't done the first 2 projects of the series yet, highly recommend you check that out before coming into this project. But if you haven't done those 2 projects either, we actually have a few setup steps that help you get up to speed very, very quickly. So it's kind of like a highly recommend you do those 2 projects, but not completely required. So with all of that kind of, hey, do I do this project? Do I not? Out of the way, here's a quick introduction to the project. Okay. You don't need any experience in Kubernetes at all to do this project. And here's why Kubernetes is important. Picture this. You've just learned how to package your app into a container with Docker, and you've done that in the last project. And now, with that API containerized, you can run it the same in any system. Nice work. But what if you need to run several containers? Maybe one container specifically for your API, another API, another container for your database, and more to handle extra users or features. If a container crashes, how do you scale your containers? What if a container crashes? How would you kind of use containers to, rescue those kinds of situations? How would you scale your containers to meet a traffic spike or make updates without downtime? So once you've mastered containerization and how to even containerize something with Docker, managing those containers at scale becomes the next challenge, and it's a real one too. That's why Kubernetes exists. So Kubernetes automates deployment, recovery, scaling, and networking for containerized apps. It solves a really big and common problem in production systems, and it's also become the second fastest growing project in the history of open source software, with 96% of enterprises using it. I really like the keyword enterprises in this introduction because it is very true that Kubernetes is a bit of a problem. Kubernetes is a bit of a tool you bring in with scale. So if you have a very small app and you're only just containerizing that app itself, maybe Docker in itself is enough as a solution. And as you just have more and more containers, which becomes something you bring in as you get more users or as your app gets bigger and more parts of that app needs to be containerized, that's when you bring in Kubernetes. So if you're looking at some sort of problem where, hey, how can we make this app work the same in every single system, it's easy to be like, oh, containerize it, and use Kubernetes to handle scaling. But that second part, whether or not you use Kubernetes to handle scaling, is actually a discussion for later. So we are learning this concept almost early on in our DevOps journey, where actually this becomes very important when an app grows and scales. But definitely if you're thinking about hey, how do enterprises manage containers, Kubernetes is a very common solution, and that's why learning it now is great. It's great too. Okay, so with that introduction, in this project, you are deploying your containerized RAG API to Kubernetes using Minikube. Yo, have you heard about Minikube before? If you are new to Minikube, Minikube is a tool that lets you run a single node Kubernetes cluster on your local machine. It's perfect for learning Kubernetes, developing apps, testing deployments without needing a full cloud environment. Because typically, if you're using Kubernetes in your job, you're probably not using Kubernetes, you're probably not using Minikube. You're probably using something else that's probably a lot heavier, takes longer to run, probably costs money. But in our case, using Minikube keeps everything free and easy to use. In fact, you can even pop over and ask if you like and say, what do enterprises typically use instead of Minikube? If you're curious, you can always ask your follow-on questions here. And expect an answer to pop out in just a couple of seconds. So by the end of this project, we're gonna have a local Kubernetes cluster running on your computer. There's gonna be a deployment that's orchestrating your containerized app and a service that's providing stable networking. You don't need to know what all these concepts mean straight away. But deployment and services are definitely key in the land of Kubernetes. So you've got deployment, this one over here, and you've got service over here in this diagram too. And here we go as well with an answer already for what enterprises use instead of Minikube if you ever want to dig deeper. But yeah, and for this project, we can open up this diagram to better understand how everything is going to fit together once we've built what we're building. We've got you, engineer here, and you are going to send a request to your API. As a recap, your RAG API is here to help you answer questions based on the documents that exist in a knowledge base. And in our knowledge base, we've got a document that's called k8s.txt, and it contains a very simple explanation of what Kubernetes is. Before we had that document in our knowledge base, our API was really confused when we ever asked it any questions about what is Kubernetes. It started spitting out answers about how Kubernetes is a dessert, it is some sort of game character, it is a country. It really didn't know what Kubernetes was, so it started to make up answers. And the power of using a RAG API is once we brought in our own definition of Kubernetes, our LLM behind that API could actually reference that document and come back now with a very proper answer of what is Kubernetes. So now that we are containerizing it and deploying it onto Kubernetes, something that really changes is the networking of your API, and basically when you ask your question, where does the traffic flow? In the first project, simply that traffic flows into a server that you are running locally. And in the second project, when we containerize it, it actually goes to your container. And now in the third project, it goes to your Kubernetes cluster. So when you send a request to your API, it goes straight to your Kubernetes cluster. And there is a part of every single Kubernetes cluster that's called the service. And it's responsible for basically routing those requests to the right pod. And here is a pod. In our project, it's going to go into a pod, and pods are basically groups of containers that are actually running your app. So it's going to say, in our case, it's a very, very simple app. So there's only a single pod that's running your container. But in other bigger situations, there are probably multiple pods, and some pods are the right ones to run your question or your request, and some pods aren't. But anyway, the service is responsible for routing things to the correct place, and it routes you to the correct container that's running your app. So here's your app, here's a container, it's running the app that you've developed, and once it gets there, your app is going to do its thing. It's going to respond with an answer. And part of that, generating that answer, is actually going to Ollama to ask, hey Ollama, I've got these raw results in my knowledge base. I think this text file matches what the user is asking for. It's asking about Kubernetes. Here's this text file that I've got that matches what they're looking for. And Ollama says, okay, based on the raw text that you've got, and the question that the learners asked or the users asked, let me generate a proper paragraph response that you can send back to your user. So Ollama generates that response, and Ollama returns the generated answer. You might notice that here. Whoa. Ollama returns that generated answer, and it goes back to your container. So now your app, which is in that container, it's running, your container is running that app. Now that it's got that generated answer, it's going to return that answer to your service over here. And your service, remember, it is kind of like the networking traffic organizer of your Kubernetes cluster. It's going to say, okay, I've got this answer. I should pass it back to the user. So the service is now responsible for passing that final response back to you. We haven't really quite mentioned the deployment here because it's not really a part of the networking, right? It's not really a part of where your request goes and how it flows. The service is a key part of that. But over here, we talked about how the deployment orchestrates the containerized app, and it does that by actually making sure that there's always a running container that's running your app. Because if there are no pods and no containers running your app, it doesn't matter where the service is working or not. It really needs to direct responses or direct traffic to working things. So the deployment is kind of responsible for making sure there's always a healthy pod, a healthy container that's running and capable of servicing these requests. And that's why services and deployments are so important. Okay, so that was a bit of an intro into what we're building, and are you excited to build it with me? I am. I know I am. In this project, or in this demo today, we're going to be going through the step-by-step guidance version of this project because, every single click, every single step, let's just do it all together. But if you're feeling a little confident, and we love confidence, you can always try out the some guidance version of this project or the on your own version of this project, which provide little and then very little and then very little guidance. So a lot of the work you can work out yourself, and always use Ask to help you along the way. Okay, so if you're up for a bit of a challenge, you can also quiz yourselves on some of the core concepts of this project. So I'm going to generate this quiz now. It's going to create some quiz questions. Let's see how we fare. You're not supposed to know, you're not expected to know all of the key concepts before you even do the project, but this is a great way for you to, practice some active learning where you're like answering quiz questions and really thinking about these concepts ahead of time. Question 1. What's the primary role of a Docker image in the context of deploying an application to Kubernetes? Oh yeah, so what's the relationship between projects 2 and 3 of the DevOps and AI series? Well, what manages the lifecycle of pods within a Kubernetes cluster? Is it a Docker image? Do you think so? No, that was probably the deployment manager. Is it to provide a stable network endpoint for the application? Does a Docker image do that, or does your Kubernetes cluster's service do that? Remember, service equals like the networking side of things for your containerized app when it's running inside a Kubernetes cluster. Is it to orchestrate multiple containers across a cluster? Pretty sure that's the role of Kubernetes itself, so that's a fishy response. What about D? To package the application code, dependencies, and settings into a portable, read-only unit. Now this looks great. That's exactly what Docker images do. They package application code, dependencies, and settings into a read-only unit, and it pretty much tells Kubernetes, hey, this is what we're running. Kubernetes says, okay, great, this is what we're running. Now I can handle the scaling of containers that is running this containerized app. So D is a great response. Let's check it. And it looks good. Okay, next up. So what is the primary purpose of a Kubernetes deployment? Is it A, to package application code and its dependencies into a container? B, to provide persistent storage for application data? C, to define a stable network endpoint for accessing a set of pods? Or D, to declare how many replicas of an application should be running and ensure that state is maintained? So this is great. It really digs into the definition of a deployment. And this is very similar to the definition of Docker. So if this rings a bell and you're thinking, hey, I kind of feel like I learned that when I was learning Docker, then you're on the right track. B, to provide persistent storage. Well, do we think that's what the Kubernetes deployment does? Remember that the Kubernetes deployment is actually here to make sure that the app maintains healthy, because there are pods and containers that are running your containerized application. So maybe storage is a part of that. C, to define a stable network endpoint. We kind of learned that is actually Kubernetes Services job. So that leaves D, to declare how many replicas of an app should be running and ensure that state is maintained. D looks really great. It is true that as a part of the deployment's job, you have to tell the deployment, hey, you know that the app is healthy when there are this many pods running. So the deployment is making sure that state is always maintained. Nice. All right, what is Minikube primarily used for in this project? Minikube, do you remember we kind of talked about that in the introduction? What do you think? So we know that for Minikube, is it here to build Docker images from Docker files? Is it here to manage external network traffic to Kubernetes services? To run a local Kubernetes cluster on a personal computer? Or to deploy applications to a production cloud environment? As a reminder, Minikube is kind of like a way for you to run single cluster Kubernetes clusters. Oh my gosh, that sounds so technical. But it basically is a way for you to use Kubernetes locally on your computer for free and at a smaller scale compared to production grade Kubernetes clusters. So with that little hint, it might feel a lot clearer that Minikube is simply here. We're using it to run a local Kubernetes cluster here on your own computer. All right, and what does self-healing refer to in Kubernetes as demonstrated by deleting a pod? Oh my gosh, this is a part of our secret mission. So I feel like it's giving you a bit of a spoiler about what we're doing in our secret mission, which is at the very end of our project today. So I might just help us out here. Intuitively, you could also challenge yourself in wondering, hey, what does self-healing mean? So Kubernetes provides a stable network address that never changes. Is that self-healing? Does that give self-healing vibes to you? Or does self-healing mean Kubernetes automatically scales up the number of application replicas based on traffic? Does it mean Kubernetes automatically updates the application code to the latest version? Or Kubernetes automatically creates a new pod to replace one that crashed or was deleted? This one looks good. So self-healing is literally this. It's this trait that Kubernetes has where if you have a pod, which is, remember, kind of like a group of containers, if that group of containers fails, Kubernetes can automatically create a new pod to replace it so that your app just continues to run without fail. Now, as a little kind of new question as well, do you remember what is the component or the part of Kubernetes that's responsible for maintaining that? So that's going to be the deployment manager. Again, these are like all new concepts as well. So if they're all feeling new, just know that you get to learn these hands-on. This is kind of like a concept preview for us. Next, why is a Kubernetes service necessary for accessing your RAG API even after a deployment is created? Is it A, the service is responsible for restarting crash pods automatically? Are services required to install system tools? Does the service build the Docker image that the API runs on? Or is it that pods have ephemeral IP addresses and a service provides a stable, consistent network endpoint? So it's actually D here. Why is a Kubernetes service necessary for accessing the RAG API? So the deployment, creating that basically creates a deployment manager, which is responsible for restarting crash pods. And ephemeral IP addresses is going to be a concept we learn about soon, but it's pretty much about how basically if services didn't exist, the URL or the way we access our containerized app is going to be really confusing. Services exist, that single point of networking, services is that single point of networking here where you don't have to worry about like, hey, where do I send my API request? So do I send it to this pod or that one or that one? And oops, like 3 just deleted, 2 just restarted. They all have new addresses. Now I need to send them to new addresses. you can probably imagine that it can get pretty confusing pretty quickly. And that's why services are here. It's that single point of like, all right, doesn't matter what's going on the pod side of things. I just need to know that if I have a request for my API, I simply send that request to the service, and the service is responsible for keeping up to date on which pod it should forward that request to. So shout out services for making your app really easy to access. Yeah, pods have ephemeral IP addresses, which we'll address very, very quickly. And our last question, what is the main function of kubectl? Or kubectl? Those are different ways you can pronounce it. So kubectl is something that we'll see pretty much in the last step of this project. No, maybe not the last. I think we'll see it in the middle of this project, probably like around here. And is it A, to provide a graphical user interface for Kubernetes management? Is it so that you can interact with Kubernetes clusters? Is it so that you can start and stop the Minikube local cluster? Or is it so that you can create and manage Docker images? Now, creating and managing Docker images is definitely Docker's job, so we can strike that off pretty quickly. But what about the rest? What about the other options? You've got a graphical user interface. You've got interacting with Kubernetes clusters, deploying apps, and inspecting resources. This one seems pretty interesting. And you've got to start and stop the Minikube local cluster. Well, starting and stopping a cluster, Minikube is probably responsible for that. But once you create that cluster, how are you going to interact with your cluster? That's something that kubectl is going to help us with in this project. Awesome, team. So we've just completed the quiz, and if you're thinking, damn, I don't think I could have answered any of those questions myself, just know that the project is designed to help you with learning these concepts hands-on. So have confidence that you're gonna figure it out very, very soon as we do this project together. Okay, so let's take a moment to set our intentions and understand what we're here to build. What are we here to do today? In this project, we will deploy our RAG API using Kubernetes. We're doing this project to learn how Kubernetes works, and why people use them today. What will Kubernetes help us with? Kubernetes will help us with managing and scaling containers, which is extremely useful at scale, i.e. when you've got a ton of containers that you need to coordinate. Okay. So, before we deploy anything to Kubernetes, we're just going to make sure we've got a Docker image ready. As a reminder, we learned about Docker images in the last project. But, refresher. A Docker image is a portable, read-only package that contains your app's code, dependencies, settings. Think of it like a blueprint or a recipe. It just has everything your app needs to run, but it's simply not running yet. There's a very important reason why we're actually talking about Docker images before we're diving into installing Minikube and using Kubernetes. So the key reason is Kubernetes can only run things that are already packaged. Docker comes first because it packages your app and everything it needs into a container image, which is that single portable unit that runs the same on any machine. Kubernetes then uses that image to create and run containers. It decides where they run, how they run, it keeps the containers alive, but it never builds the image itself. So because of that, it's kind of like a waterfall effect where you really need to figure out Docker images before you think about Kubernetes. And that's kind of the reason why Kubernetes is project 3. First, figure out what's your app. That's project 1. 2, figure out how to containerize it. That's project 2. And then 3, figure out, once you've containerized it, how you can run and scale that app, which is project 3, this one. So in this step, we're really here to just make sure that we are building a Docker image that we can then use for the rest of this project. In this step, I'm setting up a setting up a Docker image. We need a Docker image because Kubernetes requires one so that it knows what kind of containers it's running, scaling, managing, etc. Just as a little bonus, we can also define what a Docker image is, which is a portable read-only package that contains your app's code. Just a package that contains our app's code, dependencies, and settings. Great. Done. So to do this, we have set up a bunch of scenarios based on whether or not you've done the first 2 projects of this series. In this demo, we're going to assume that you have. You can definitely check out the first 2 project demos as well to also get up to speed on context if you want to take the more, detailed, learning-focused route, which is to do those 2 projects first. But if you're keen to speed run things a little, you're feeling really excited about Kubernetes, don't worry. Open up this project guide in your on your computer and then follow the new steps that we've kind of written specifically for you. And you can find the link to this project in the description of this project demo as well. Okay, so let's open Cursor on your computer first of all. I'm going to press Command Space to open up Spotlight. You can see that here. And we're going to type in Cursor and press Enter to open up Cursor. So Cursor is the IDE that we're using to basically write our code and also use an integrated terminal kind of UI in the same page. So Cursor is going to open on your screen, and we're going to select Open Project so that we can start working on it too. Oh, I just realized you can't see this right now. Wait a second. Whoa. Can you see it now, team? Come on. Hey. Okay, so here's Cursor now opened up. And we're going to click on Open Project. Have you done projects 1 and 2 in this series? Well, in this demo, we are going to assume that you have. So welcome back, and let's get set up so that we're ready for Kubernetes in the next step. Again, if you have done project 1 but not project 2, here's what you should do. If you haven't done either project, here's what we should do. So you've got all the steps ready for you. Okay, so we're going to select Desktop to open up our project because we have already created the app and we've already containerized it. So there are some important files that we've already got that's going to help us get up to speed very quickly. So open up your RAG API folder, your network-rag-API folder, and select Open like this. Great. Whoa, spoiler. Okay, but this is what it should look like once you've opened up your project. Okay, here you go. And we're gonna check that you've got a Docker image. So we're gonna go into our terminal. You can see it. I can find terminal in my menu bar, and I'm gonna click on New Terminal to open up a terminal. And in this terminal, if I've got $1 for every time I say that word, we're gonna run this command and press Enter. Okay, I'm also just going to hide my File Explorer so that we've got more space here. And I'm going to press Command B to do that. And let me just expand this. So we've got lots of real estate showing us what's happening in the terminal. Docker PS. And I'm just going to hide this for now, hide tabs. So we've, again, got more real estate on the terminal itself. Eee! It doesn't look very easy to read, does it? But here we've got the results of Docker PS. I'll zoom in on this very quickly. And this basically is a command that lists all of the running containers. And here, if you see a list or a table, you should see, you know, a container ID, your image, a command, so on and so forth. If you see like, hey, I can't connect to Docker daemon, no worries. It just means Docker desktop isn't running yet, and here are some instructions on what you could do. All right, but I see that list. It looks good. So we're gonna run a command to check what Docker images are in your computer. And let me just zoom in now, actually. So we've got Docker images, grep ragapp, that's the command for Mac. And it basically looks through all of the images that exist in Docker desktop, and it looks specifically for any image with the name ragapp. That's the name of the image we built in the previous project, and that's why we're searching for it specifically. So it's gonna list all the images that you've got. We've only got one with that name. That makes it very easy to spot. So perfect. We've got the Docker image with the name ragapp. Okay. So here it is listed, and it looks good. So if you see a different Docker image name, you might have done the secret mission in the previous project, which would have renamed your image probably to a different name. If that's the case, you can simply type in the name of your ragapp image into here, and typing it into here just makes sure that all of the commands later on in this project actually matches up to what your image is called. Otherwise, the default is rag-app, which is what I've got, so I'm just gonna keep this like this. Okay, so you've got your Docker image from project 2. Well done. You can now jump to the end of the step. You know, you don't have to do all of that setup that I guess you'd have to do if you were doing setup. And you know, I got stuck. I suddenly lost my words, but you would have had to do that setup if you didn't do projects 1 or 2 of this series. But since we have, here we go. We're already at the end of step 1, and we're ready to get going with steps 2 onwards. Okay, so let's upload a screenshot of your Docker image, and let's take that cheeky screenshot like this, and let's upload that into your project guide and answer this. I ran Docker images and saw that I've got a Docker image called ragapp. The image size was 1.35 gigs, so pretty hefty. The image ID was this one, this thing here. That's your image ID. Great. Well done. So just like that, we've got step 1 done. You now have Docker image ragapp built and verified. You've got Docker desktop running, and you're ready to deploy to Kubernetes. So now let's install the Kubernetes tools you're gonna need. All right. To set up Kubernetes, there are 2 tools that we're gonna need to install now. So the first one is called Minikube. So that's a tool that lets us run a single node Kubernetes cluster on your local machine. And the second one is called kubectl or kubectl. Hover. Okay, and that is a command line tool for controlling clusters once you've started one up. So this is for creating and running a cluster, and this is for controlling that cluster once it's running. And we're gonna need both today. Okay, and really, why Kubernetes? A reminder that Docker is great for running a single instance of your RAG API, but if you want to run many containers, that's when Kubernetes comes in. So in our case, Kubernetes is going to manage our RAG API containers, like starting those containers, stopping, scaling them, and it does it by organizing them into a cluster of machines that work together to keep your API running. And every cluster can have multiple nodes, and all of those nodes will have their own pods. And basically, you can think of containers as the lowest level, and groups of containers are in pods, and groups of pods are in nodes, and those nodes are in a single cluster, a single Kubernetes cluster. So that level of hierarchy and organization is basically what makes scaling containers very, very easy using Kubernetes. And in this case, we've got these two tools that we're using. So there's Minikube and there's kubectl. And Minikube, again, it helps us run that local Kubernetes cluster, and it's free to use. Yay! And it's also very easy to use. Yeah. But to actually control that cluster once you were running it, we're going to be using another tool called kubectl. So let's install them both at the same time. Okay, so in this step, we're going to be installing Minikube and kubectl. We need these tools because Minikube is responsible for, actually, let's rewrite that too. We need these tools because we're using Minikube to run and to start and run Kubernetes clusters. And then kubectl is useful for running commands that lets us control our clusters, e.g., I would say there are actually examples here. So you can use it to deploy applications, inspect resources, view logs, manage your cluster, e.g. view logs, show what services and pods are running. And there'll be more examples later in this project too. Yay! And as we do these responses, by the way, did you know that you are automatically creating documentation? So as you answer every single question, it is always fun to check how your documentation is building. This is already looking great, and imagine how it's going to look once we answer all of the tasks, once we complete all of them in this project. So let's install Minikube for your operating system. In the Mac OS case, we're going to just make sure that we've got Homebrew installed first before we actually install Minikube. For Windows, you've got the Windows instructions right here too. All right, so we're going to run this command, make sure we've got Homebrew, and we've got it because we've got a version number here. And always, if you are stuck, there is some help guidance within the project guide, or you can also click Ask here, or you can check out the Nextwork community, and there's going to be someone doing this project with you, I'm sure, in the community too. All right, and with Homebrew, we're going to install Minikube. So run brew install Minikube. Off you go. And the first time you run that command, it's probably going to wait. It's probably going to take a few minutes. So expect it to take, that amount of time. Don't be like, oh my God, it's been 30 seconds. What's happening? It's totally normal. It actually that command tells Homebrew to download and install Minikube on your local computer. And once you have run that command, it was very quick for me because I've definitely installed Minikube already. You can run Minikube version, and it's going to give you a version number, which is basically how you confirm that Minikube is now properly installed. So perfect. Just like that, we've installed Minikube. This tool is going to be helping us with starting and running Kubernetes clusters very, very quickly. So it's good that we've got it going already. Okay, And next, let's install kubectl, the Kubernetes command line tool. It connects to the Kubernetes cluster that Minikube creates and lets you run commands to deploy apps, check status, view logs, and more. Again, we're going to use Homebrew if you're on a Mac to install kubectl. And done. It might take a minute or two the first time. Very fast for me because I've installed it before. And you might see something that says, hey, warning, Kubernetes CLI 1.35.0 is already installed and up to date. Don't worry if you see that, it's totally normal. It actually just means that when you installed Minikube, kubectl was already installed for you because it was kind of, you can say, a dependency that Minikube needs for it to actually run. We always just try to install it ourselves anyway, just in case. But if you see that, it's totally a green flag. It's totally fine. You can skip this warning and move on ahead to the next step. And the next step is to just double check that kubectl was installed successfully. And we're going to do that by, classically, checking its version number. The command for that is kubectl version -- client. So let's run that in our terminal too. And I can see that I've got a version number, so that worked perfectly for me. Now, this command, that -- client flag basically tells kubectl to only show the version of the kubectl tool itself, not the Kubernetes cluster version, since we haven't started a cluster yet. So once Minikube is running, you can actually run kubectl version, and now you can see both the client and server versions. That's just a little extra tip for you. But anyway, you might see that we see two version numbers anyway, because there's a version number for the kubectl command line tool we've installed, and also another version number for Kustomize, which is a tool that's built into kubectl itself. We don't actually need Kustomize, but if you've downloaded kubectl, you probably have both. All right, so we're just going to verify another thing before we can move on, and it's whether kubectl can find a config file. It's probably not going to have anything on that file yet, but this basically helps us with testing our kubectl setup. Okay, and that config file is kubectl's address book, so it stores information about which Kubernetes clusters kubectl is connected to, how to authenticate with them, which cluster to use by default. So it's kind of like a manual that kubectl refers to understand each of the clusters that we might be sending commands or like trying to control. So right now, that config file is probably going to be empty if it's your first time running Minikube and kubectl. And if that's empty, that's totally fine. Mine might have a bit of information because I have installed and run kubectl and Minikube before. And yes, it sure does. And that's totally okay. What you might see is probably something more like this, which is what an empty state for kubectl will look like. Okay, so if you've got an error, you can troubleshoot here, but overall, you should be able to just see an empty config file like this. Don't forget, we've kind of run this command just to double check whether kubectl has a config file at all. So not entirely important in this project for you to understand what each of those lines mean, but as always, you can always explore your curiosity and learn about each line if you'd like. We've got definitions ready for you here. All right, so let's upload a screenshot of your Kubernetes tools. And then we're gonna have a few questions here too. All right, I think we've checked the version numbers of Minikube and kubectl here. So why don't we, I'll just take a screenshot of this. Woo! Add that to the project guide and answer this question. So we installed Minikube using, what do we use? We used Homebrew for us. And the simple command, brew install Minikube, made it so easy. We also installed kubectl by running the command kubectl brew install kubectl. Both were super easy, and we could download them in minutes. We also verified that both installations were successful by checking the version numbers of each. Excelente. We can now move on to a bit of a kind of a recap or a conclusion for this step, which is that you now have Minikube and kubectl. So what is the actual difference between them? Minikube is used for creating and running Kubernetes clusters locally. In contrast, kubectl is used for sending terminal commands that helps to control our Kubernetes clusters once they're running. They allow us to create and control clusters. That's it. The key difference between them is that one is on the creation of clusters, and the other is on controlling it. Cool. I hope that makes it super clear for us. Nice. Okay, that brings us to step 3. So once we're done with this, we're kind of at the halfway mark of our project today. And step 3 is where we start to actually use the tools that we are installing to create that Kubernetes cluster. So what is a Kubernetes cluster? Why do we need one? It's a bit of a chunky explanation here, but it is such a key part of this project. So why don't we spend the extra minute on understanding Kubernetes clusters? Have a quick read if you'd like, and then we'll go through it together. Okay, so Kubernetes and clusters are the foundation that makes Kubernetes work. It is a set of machines, a cluster's set of machines called nodes that work together to run and manage your containerized app. You really can't use Kubernetes without a cluster. It's kind of like how, without containers, you can't really have Docker. So think of it like this. Docker runs containers on a single machine, but Kubernetes needs a whole cluster to orchestrate the containers across multiple machines, handling failures, scaling up or down, managing networking. In production, clusters can have hundreds of nodes spread across data centers, and Minikube creates a single node cluster that's perfect for learning. It is a real cluster still. We are still creating a real Kubernetes cluster. It's just that it is smaller and probably much smaller than production grade clusters. This cluster will manage your RAG API containers, starting them, restarting them if they crash, scaling them when needed, and routing traffic to them. Alrighty, so in this step, we're going to start a Minikube cluster. We're going to make sure that the cluster is actually running, and then we're going to load our Docker image into Minikube. So in this step, we're starting a Minikube cluster. And Minikube, well, I think that part we probably can leave off of this answer. Simply in this step, we're here to start that Minikube cluster. We also need to load a Docker image into Minikube. So that Minikube knows what app. So the Minikube has an image it can use to spin up containers that it will scale. So that Minikube has an image it can use to spin up containers that will run the RAG API. Cool. Let's select done. Scroll. So let's start our Minikube cluster now. If you had path issues with Minikube during installation, so if Minikube version didn't work earlier and you're using and you had to use the full path to run Minikube commands, just a heads up to keep using that full path. And if you prefer, you can also just sort out the path issues using the ask as well. This is a very, very handy tool for sorting out any special unique issues. Otherwise, if you're like me and running Minikube didn't give you any path issues, then you can keep on going with the default commands we're giving you in this project guide. Okay, so let's run this command in your terminal and press enter. Off we go, Minikube start. Okay, here we go. This is a cluster now starting up in front of us. You can see that there are some different status updates here. Minikube, we're using version 1.37. It's using a Docker driver. It's starting Minikube. It's pulling a base image. It's noticing that there is a Docker Minikube container that's missing, which it will create. So these statuses can feel very, very detailed, but at its core, what this command does is it creates and starts that local Kubernetes cluster on your machine. It downloads Kubernetes components, it sets up the networking, and it starts all the necessary services. So it's going to take about 2 to 5 minutes the first time. Please don't close your terminal while you wait, because Kubernetes or Minikube is off doing all of these so that you can have a working Kubernetes cluster for you to run your containerized app. Let's just make sure all of this is set up properly. Now, if you'd like, here's a creative way you could use ask. You could copy all of these status updates. You can put them into ask. Can you give me a simple and concise explanation for each of these status updates? Okay, and off we go with ask, explaining all of these to us. Shout out ask. Okay. Oof, the formatting is a bit chunky, but it's okay. So we've got, Minikube version 1.37.0, and this tells us that the version of Minikube we're running is version 1.37. The operating system it's on is macOS. I think what it knows that based on Darwin. And then using the Docker driver based on an existing profile, Minikube is using Docker to create a local Kubernetes cluster, and it's using a previously saved configuration. So this is probably because I have run Minikube before, but if you still see this, it would tell us that there would have been a previously saved configuration using Docker, and if you've already got Docker installed, that might be where it's coming from. Starting Minikube primary control plane node in Minikube cluster. Minikube is beginning to start the main part of your Kubernetes cluster, which is called the control plane node. Yeah, this is getting into a little bit more into the nitty-gritty of Kubernetes clusters, but the control plane node is the brain of a distributed system that helps to manage and orchestrate the worker nodes. So if you were to actually peel back the curtain for a Kubernetes cluster, there's a single control plane node, and then there are multiple worker nodes. And the control plane node is responsible for things like scheduling, maintaining desired states, handling cluster level operations. And then you've got the worker nodes that are here to actually run the RAG API. So these are all split into two different kinds of nodes, and then it's pulling a base image to create the Docker container for your Kubernetes cluster. So you might be noticing that there's really a lot of Docker kind of references here, and that's mainly because Minikube, when we're starting a Minikube cluster, we're actually creating and running a Docker container running Minikube. So it is kind of like containers. The Kubernetes cluster we're running is actually inside a container as well. And then once we're running that, once we've got that container running, it's got Kubernetes inside it, it's got Minikube inside it, and then we're gonna go inside the container, and then Minikube's in there, and we're gonna give Minikube our own Docker image, which has a containerized RAG API, and then from that Minikube cluster, it's gonna actually run more containers inside it within that cluster that's going to be running the RAG API. So we're actually going to have like containerception. If you've watched Inception, it's kind of like container in a container. We've got a container for our Kubernetes cluster, and within that there's going to be containers that's actually running our RAG API. So 2 layers of containers basically. And as you can see, I've actually run into an error here, and it's an error that I'm familiar with, so I'm not freaking out, I promise. But here, there's an error going on. Error validating something. If you choose to ignore the errors, turn validation off with validate equals false. Is this an actual error? Doesn't feel like one. Let's have a look. So, default storage class. So probably something to do with storage within my Minikube cluster is causing an error right now, but I wonder why. Let's see if Ask can help us today. It looks like you're encountering some common errors during Minikube startup related to add-ons like default storage class. This is actually normal. It's common to see errors like connection refused or add-on failures during Minikube startup. These errors are usually harmless and don't affect basic functionality. You should just wait for the done message and just check that your cluster is healthy. Good to know. Thank you very much. Oh, there's a totally different error though. Seems like we've exited the Minikube cluster setup process because of something else. Exiting due to Kubernetes API server missing, waited 6 minutes for a node, waited for API server, but the process never appeared. Check that the provided API server flags are valid and that cell Linux is disabled. Whoa, interesting. Now this is my first time seeing this issue, so let's see what's going on. I hope you're not running into the same errors as me. If you aren't, it means that you're safe to move on. It should honestly look like this. and it should just say done. Kube control is now configured to use Minikube cluster in default namespace by default. So that should be what you see, but it's totally okay if you see errors. In fact, we really do expect them and we welcome them and they help us with learning, so it's totally okay. And in my case, I feel like we're seeing an error that's not even covered here. Could be an add-on error. I think I actually have an add-on error. Oh, this is what I'm seeing. We can check. We can try to delete and recreate the cluster, which could help resolve underlying issues. So let me go ahead and do that and report back on whether that works. Well, Minikube delete first. Minikube start. Great. Update team, so we've just deleted the Minikube cluster and started it again, and that actually seemed to have resolved the issue. So it seems like something might have happened when we were starting that Minikube cluster initially that just didn't replicate when we tried to start it one more time. These kinds of errors can lead us to scratching our heads, but truly it does happen quite a bit. I've actually run into lots of errors before trying to start a Minikube cluster because I've run out of space in my local computer. So that could also be a totally valid reason if you're finding that you're running into errors here. But okay, good to see that we've kind of gone through that barrier. Let's keep on going, shall we? So now that we can see that successful done message, woohoo, we can go and verify that the cluster is ready. So here is a command, kubectl get nodes. And it tells us that we've got a node called Minikube, and we've got a status that's ready, and more. In fact, this lists all the nodes in your Kubernetes cluster, and because we've got a ready status over here, it means that Kubernetes has already finished starting up all the necessary services on that node, and it's ready to run containers. If the node wasn't ready, Kubernetes wouldn't be able to deploy your RAG API containers to it, so it's important that we see that ready status. Okay, and this is the part where we talk a little bit more about nodes. A node is a machine that runs your containers. In production, clusters have many nodes, but Minikube creates a single node cluster, so there's just one machine running on your laptop. This single node will run your Docker containers and manage them. It's perfect for learning Kubernetes without needing multiple machines. Again, this is just that kind of Kubernetes container in container effect, because we had to use a Docker image to create our Kubernetes cluster, and now that Kubernetes cluster is of course going to be running multiple containers, and that's going to be where our RAG API is running. And here, a node is simply a machine that runs your containers. So in our case, we've got Docker containers to do that for us, but you could also use physical servers to actually run your containers as well. Okay, we're ready to continue. So we've got that ready status that looks perfect, and that means our Kubernetes cluster is running. So let's take a screenshot of the running cluster. Kubectl get nodes is the perfect proof for that. If you like, I personally really like the many emojis in the status updates when you run Minikube start. So you can also use that too. And once you've uploaded that, what commands did we run to start the cluster? We started the cluster by running Minikube start. And we saw lots of status updates in our terminal as Minikube prepared and started the components necessary for, oh, actually, they're called services, necessary for our Kubernetes cluster to work. Then we ran kubectl get nodes to load our image. Kubectl get nodes showed the status as ready, which tells us that our cluster is ready for us to load our Docker image. See? And again, as you answer each of these, you can see your answers. As you answer each of these tasks, you can see those answers populate your documentation, which is coming along very well. It looks pretty impressive already. Okay, so now that we have our cluster ready, the next step is to load that rag app Docker image into Minikube. And Kubernetes, again, needs that image because containers come from Docker images. Kubernetes can create images, but Kubernetes cannot create images, so it needs you to load one. Your rag app Docker image already contains everything your rag API needs to run. The Docker image includes the code, the dependencies, configuration. So when we say we need to get your Docker image into Minikube, it means it needs to be available to Minikube's Docker system. This way, Kubernetes, which runs inside Minikube, looks for the image. When Kubernetes looks for that image, it can find it inside Minikube's Docker system. So you might notice that we're talking about Minikube having its own Docker storage, its own Docker system, and that is because your local computer has Docker running, but once you've got Minikube running, Minikube is in its own environment with its own Docker system. So it's pretty much like a separate device that you're running on your own device. These Docker systems don't share files automatically, so even though you've got the rag app image already in your local Docker storage, you actually need to load that into Minikube's Docker storage too. So that's why this is a completely other step that we need to do even after you've started running your Minikube cluster. So with that, first we're just going to, make sure that we've got a Docker image that we can load into Minikube, and once we've checked that, we're going to load that image into Minikube. So this is the command again for checking that you've got your Docker images. And here we go, we've got rag app over here. We can see that's 1.35 gigs, but it confirms to us that our local computer has a Docker image. So you've got that image, and we're gonna now get it into Minikube. So now within this terminal, we're gonna switch into Minikube's Docker environment. We're gonna run this command called eval $minikube docker env, and we're gonna run that here. I've honestly never run a command like this. It's so interesting. But this command sets environment variables that redirect your Docker CLI to use Minikube's Docker daemon instead of your host Docker daemon. It's like switching which Docker server your terminal talks to. So now, after you've run this command, when you write docker build, it's going to build images inside Minikube's environment. Docker images will show Minikube's images. Docker PS will show the containers running inside Minikube's environment. This kind of change in the server your terminal talks to only exists inside this current terminal window, this current session. So if you open a new terminal, all of the Docker commands you run there, it's going to point to your host Docker again. If you'd like to verify that you're actually using Minikube's Docker, you can run docker ps, and you should see Minikube's Kubernetes containers running. And these containers, there's so many of them. It honestly freaked me out the first time I saw it. I was like, oh my goodness, that's a lot of containers. but you can tell that it is a Minikube Kubernetes container by checking its name. Well. Okay, do you see how the names here all start with K8s underscore? That's how you know it is a Minikube Kubernetes container. And this wouldn't be running if we were just running Docker PS in our local kind of Docker environment. It would have just given us probably the container that's running this Minikube cluster. It would have just been one result. Awesome. So we're gonna navigate to our project directory if we're not already there in our terminal. Okay, and we're just gonna now build our image in Minikube's Docker environment. So that's what we mean by loading that Docker image into Minikube's environment. It basically just means we're building it from scratch again in here. So we're going to see the same build output as when we built that Docker image in our local environment. This would have happened in project 2, or if you set up your project from scratch in this project, you would have seen this output probably in your terminal. So it's going to take 2 to 3 minutes, which is around the same time as when you had to build it in your local environment. And once it's built, we're going to just verify that the image is in Minikube. This. All right, you can really see a lot of these status updates happening. Damn. I really enjoy this project, and whenever I'm waiting for something to run, I really do enjoy going back, thinking about the responses I've already submitted, and also asking, using Ask to just enter 1 or 2 questions for fun and for learning a little bit more. All right. Well, in this case, are there any questions we might have? Well, maybe it'd be great to backtrack and understand a little bit more about, Docker daemon. So you can actually highlight this and run this ask and say, what is Docker daemon? Why do Minikube and my local system have different ones? Be concise. Excellent. So a Docker daemon is the background process that manages Docker containers. It's responsible for building, running, and distributing your Docker containers. Minikube and your local system have different Docker daemons because Minikube creates an isolated Docker environment to run your Kubernetes cluster. Your local system has its own Docker daemon for managing containers directly on your machine, so they're separate. So again, because Minikube is kind of running in its own environment, you really think about Minikube kind of being run on a different device to yours. And because it's on a different device, it has its own Docker daemon, and that daemon is the background process that manages Docker containers. We rarely look at it and think about it, but it's kind of like just the engine that actually runs that actually runs Docker on your machine. So it is very, very important. Okay, we're gonna just jump back to where we were. And once this is all finished, you will see that you've got view build details at the end of your terminal output. I'm gonna zoom in so you can see it. Okay, and we're just gonna verify that the image is in Minikube. We're gonna do this by running the command docker image, and again grep to filter for any image with the name rag-app. And you can see we've got the rag app image, and it was built about a minute ago, so this is definitely the new image that we've just set up in this command above. Great. So first, what does this command do? the eval minikube docker env command switches the environment that our Docker commands point to. After running this command, every Docker command I ran after pointed to Minikube's environment instead of my own local environment. Without loading the image into Minikube, Kubernetes would not have an image for creating and running containers. The RAG API simply would not be running. This is different from regular Docker because Kubernetes does not create images, Docker does. But Kubernetes is used for managing and scaling containers once they're created. Okay? So Docker's strengths is being able to containerize applications, and Kubernetes' strength is being able to scale and manage containers. So it's good to have them working hand in hand, eh? Great. So awesome work, your Kubernetes cluster is ready. You have started your Kubernetes cluster, you've loaded your Docker image into it, and we are now ready to deploy your API and let Kubernetes take over managing your containers. So you can actually think of what we've done in step 3 as a part of setting up as well, because we were just creating that Kubernetes cluster and we were loading a Docker image into it, but the Kubernetes cluster technically isn't running those, isn't running your RAG API yet. We will have 2 more things we're going to create to wrap up your Kubernetes cluster setup, and that is the deployment and the service. We're going to start with the deployment. You might remember this from the introduction and the quiz, that the deployment is responsible for maintaining the ideal state for your Kubernetes cluster. It's responsible for making sure that there are always pods and containers running to keep your application healthy. Where service is responsible for making sure that on the networking side of things, there is always a stable endpoint that you can use to access your Kubernetes cluster and the API that it is scaling. So deployment, maintaining an ideal state so that it is healthy. Service, making sure that on the networking side of things, there's a stable endpoint and your API is easy to access. Okay, on the more detailed level of how the deployment actually works, you can think of that deployment as a blueprint. So when you are writing a Kubernetes deployment, you tell Kubernetes what is the ideal state of your app. So Kubernetes will always try to make sure that blueprint of the ideal state is always met. So that ideal state or that blueprint contains a few details, like which container image we're running, which is that RAG app Docker image, how many replicas or copies of that app it needs to be running, and basically the more traffic you've got, the more copies you're running. And it also helps with high availability. So if one copy has failed, there's going to be another copy that's running. It handles rolling updates. So that, if you are rolling out, a new version of your app, this deployment or this ideal state always tells Kubernetes which version it should be running. It can restart containers if they crash, and it can also scale your application up or down. Okay, and this is the extra for experts if you want to go into another layer deeper into how deployments work. Okay, so in this step, we're deploying our RAG API using Kubernetes, we need a deployment because that is responsible for telling Kubernetes how many copies of our app we're running, what version of our app we're using, etc. It defines the ideal state of our app that Kubernetes will try to maintain. Okay, great. So all done. And to create that Kubernetes deployment, we need to create a file that's called deployment.yaml. And all we got to do is in our cursor IDE, open up your file explorer. If you have it closed, you can actually just open it up using this toggle primary sidebar button, which you'll find here, up here. And then you can create a new file that's called deployment.yaml. So let's open a new file. Let's call it deployment.yaml. And we're going to click enter, and let's click on the file to open it. I like to close my file explorer so that I've always got more space looking at my key point of focus. So I'm going to just hide it again using Command B. And the deployment.yaml file is actually very simple. It's simply this, kind of just looks like this, a very simple configuration. We're going to copy and paste that in here. Okay, and to save the file, we're going to press Control S or Command S. Now, again, the deployment file just tells Kubernetes how to run your RAG API. It says, hey, this is the image that you should be running. It says, how many copies of it do you need? It says, if you're looking for which pod you should be running, how to find it. It is RAG API. That's the name of the pods that will be running the RAG API app. And then you've got the Ollama host environment over here. So that's an environment variable. And it basically tells RAG API where to find Ollama that's running on your local computer. You might actually remember this if you ran into an error with running Ollama using connecting your Docker container with Ollama in the previous project. But this is basically a special location or a special address that connects your Kubernetes container to, your Kubernetes cluster to Ollama, which is actually running on your local computer. Okay, you can always click here for a line-by-line breakdown of the code block if you'd like to dig deeper, but that is essentially what this deployment file is trying to do in a nutshell. And if you're noticing that we've got both RAG app and RAG API going, RAG app over here is simply the Docker image name, and then you've got RAG API, which is the label that connects resources. So this is the tag that Kubernetes will use to group and find pods, and it's also basically a selector that the deployment uses to find pods. In a nutshell, you've got RAG API, a label for your pods, and RAG app, which is the image, the Docker image that we'll be using. So they point to different things. All right, well, now that we've got our deployment file, all we got to do is run this command that is for applying your deployment file to create the deployment manager. So we're going to run that command here in our terminal. And what that does is it gets kubectl. This is the reason why we installed kubectl, to read the deployment file and apply it so it's creating a deployment manager. So because that deployment is created, it basically means that our Kubernetes cluster is now trying to reach that desired state or that ideal blueprint that we've written up. Okay, so part of that desired state is that we always have one pod that's going to be labeled using RAG API, and that pod is going to have a container running the RAG app. image. So if we're gonna run this command that says kubectl get deployments, this is a command that basically returns all of the deployments that your Kubernetes cluster is currently running. And it shows their status, how many replicas are running, and you can see that because you can see one deployment that's ready, it's up to date, it's available, this tells us that the deployment is working perfectly. And you can actually see the running container or the running pod using the command kubectl get pods too. There you go. Here you are. So here's the pod that's actually running as well. Cool. Okay, so you should see an output that looks like this to tell us that your RAG API pod is running successfully. If you don't see a running status, that probably means that it's taking a little bit of time to be ready. Just run that command again in about 10-20 seconds and it should be running. Okie dokie. So with our pod running and our deployment created, we can now take a screenshot of our terminal showing our deployment in a ready status. Let's do that. I like showing the commands I use to get there as well. So I'm going to take a screenshot of that command too. And I'll just add that to our documentation. Cool. So you've just created the deployment YAML file with update. Sorry team, just realized I was loading the wrong version of the task for this step. So let's go ahead with the correct versions. Earlier in this step, you would have seen a question that actually asks, what does your deployment YAML file do? So we created the deployment file and sorry for that connection error, but I've just actually finished writing up the response to this, and it basically says the deployment tells Kubernetes what to run, how many copies, how to find it, and how to connect, which is basically the bullet points that we've got over here. And that's just our deployment in a nutshell. So once you've got that response, later in that step, as we conclude, you will get this task that asks, what did you observe when you checked your pods? We ran kubectl get pods and saw that we have one pod with the name rag app deployment and with a funky ID and status ready. Oh, running. Oops. Which means the pod is now running our RAG API. The ready column showed 1, 1 here, which means one container ready out of one total in this pod. Excellent. Okay, so that is step 4 done, and now we're in step 5, which is the Kubernetes service. So your deployment is running, your RAG API in a pod, and Kubernetes is managing it, but there is one problem. How do you actually access your RAG API? Because your pod has an IP address, but that address changes every time the pod restarts or gets created. This happens because pods are ephemeral. They can be created, destroyed, and recreated by Kubernetes. They're temporary. If you try to connect directly to your pod's IP, the connection will break whenever Kubernetes restarts that pod. So a service solves this by providing that stable networking endpoint for your pods. It is a consistent way for you to reach your RAG API no matter what happens to the pod, and even if that pod gets recreated with a new IP address. So let's go ahead and share what we're creating in this step. In this step, we're creating a service we need a service because it provides a stable networking endpoint, i.e. a stable IP address that lets us connect to our API. If a service didn't exist, then we'd have to connect directly to the pod running with the container, to the pod that's running our containerized API. And this connection would break every time that pod gets restarted by Kubernetes, i.e. very fragile. Awesome. Awesome. So very similar to deployments. To create services, we start by creating that service YAML file. So I'm going to go ahead and open up our file explorer, Command B and cursor. That opens up the file explorer here. And let's create a new file and name it service.yaml. Okay, so in service.yaml, what we're going to do is copy this entire code block, paste it in service.yaml, and here we go. That essentially is our service YAML file all done. That was very quick. So what does a service file do? It tells Kubernetes how to access your RAG API. So you've got deployment.yaml, and deployment.yaml had a different purpose. Okay, and it's nice to compare them side by side. Okay, the deployment file tells Kubernetes how to run the RAG API, and then the service tells Kubernetes how to access the RAG API. You've got a few elements that comes into play when you're trying to figure out how to access something, and one of it is which pods to route to. So you've got the selector here, RAG API, which finds all pods with the label RAG API, and it basically says, hey, to find the RAG API, find all pods with this label. And that's why this label, RAG API, must match your deployment's pod labels. You can see that we had the pod labels here. So once we figured out that we want to route to pods with the label RAG API, the next thing is how do you even reach those pods? You reach those pods by actually connecting to the port 8000 in your computer. So outside your Kubernetes cluster, just connect to port 8000, and that is going to connect to target port 8000. So port 8000 in your computer is going to route to port 8000 on your pods where your RAG API is listening. So that's defined by target port over here. There you go. And then the type node port over here makes your service accessible from outside the cluster. Node port assigns a port on each node that routes to the service, and then Minikube provides a convenient way to access it. If you want to learn more about node port, you can definitely use Ask to also explore a little bit more. But in general, node port is a Kubernetes service type that exposes a service on a static port on each node's IP address. This allows external traffic to access the service through any node in the cluster on that specific port. So in short, node ports are used to make services externally accessible. Cool. So with that, when you apply this services file, Kubernetes creates a stable network endpoint for your RAG API, And it just means that no matter how many times your pods restart or get recreated with new IP addresses, you can still just access your API with the same service port. And that just keeps accessing your API very easy. Okay, so the service YAML tells Kubernetes how to access the RAG API. The selector finds pods by matching the selector label, which for our case is RAG API. And then the port configuration allows our port 8000 to be connected to port 8000 on the pod. I would say the pods port 8000 on your pods. I think these prepositions definitely trip me up sometimes. On our pods. Then node port enables access from outside by assigning a port on each node that routes to the service. By assigning a node on each, by assigning a port on each node that routes to the service. Okay, so now that we have already configured the service, all we gotta do is actually just apply this now. So we're gonna run the command kubectl apply and apply the service YAML file, which is gonna create this kind of notification that it's been created. So the terminal response, aye, your service has been created, and let's go check our status now. So we're gonna go ahead and run the command kubectl get services. And that again outputs the name of our service, what type of service, and then the cluster IP. So all the services in our cluster could be different types. So you've got cluster IP as a type of service, node port is a type of service. And there we go. So Kubernetes is the default Kubernetes API server that's always present in our cluster, but you might notice that we actually gave our service, the one we created, a very specific name called RAG app service, and you can actually see that over here. Here we go, and that's a node port service. So you might see the type is node port, and that's exactly what's shown here as well. Okay. So you can see that we've got a cluster IP, so the internal IP address of the service is this, but it is mapped to port 8000. Here you go. So port 8000 is the service port, and 31180 is the node port that Minikube has assigned. So we don't really need to worry about this. It's just plain and simple that it's mapped to port 8000. There you go, exactly like this, which is the port mapping. So when you connect to 8000, that basically just means that your Kubernetes service is going to be listening on 8000, and once the request is routed to 8000, 31180 is the port on each node that routes to the service. So then from the service, it hits every node, or it hits the node that is on the pod. Oh, just to clarify confusion, I think I accidentally said that it routes to port 3000 something in the pods, just in case of any confusion. So when you access your API, you use the node port number, which routes to port 8000 on your pods, as written like over here. So the node port number is 31180. So you would access your API using the port number 31180, and that routes to port 8000 on whichever pod is running your RAG API. Awesome. So that is a bit of networking madness as usual. And that is honestly one of the biggest reasons why services must exist to help make it even simpler for us. So with that, let's take a screenshot of our services and answer a few questions. Okay, so we applied our service file by running, what do we run? We ran the command kubectl apply service YAML. We then verified that the service was created by running kubectl get services and confirming that our service, which we named RAG app service, was running. Awesome. There we go. So with our service created, your API is now accessible through a stable network endpoint. The service will automatically route traffic to your pods, even if they restart with a new IP address. So now let's test your API and see it in action. In our next step, this is the final step of the entire project. Well done. In this one, we're going to be accessing your API using Kubernetes accessing your API through Kubernetes. And this is the moment of truth because you're now going to see your containerized API running inside your Kubernetes system. So easy peasy, or simple as, there's two things we just got to do. Test your API using node port, and then test your API through Kubernetes. So in this step, we're testing our API through Kubernetes. Okay, so in this step, we're testing our API through Kubernetes. We will be accessing the API using node port and then running the classic "what is Kubernetes" question. With our RAG API now running via a Kubernetes cluster. So we've tested our RAG API in projects 1 and 2. The first time we just tested it when we ran the RAG API locally. The second time we actually ran the RAG API when it is already containerized in a Docker container. And in this project, the RAG API is now running via a Kubernetes cluster, and we're now actually going to be testing and seeing if the RAG API still works. So off we go. To access the API using our node port, we actually have to figure out what is the specific URL that can now let us access our API. We can do this by running this specific command in our terminal. So let's copy that, paste that. And this command creates a tunnel, a connection between your computer and your Kubernetes service so that you've got this URL to access it. The URL flag returns just a URL, and that's why it's such a clean output for us. So think of this tunnel like a bridge. Since Minikube runs inside a Docker container separate from your computer, this tunnel is required so that your request can actually reach your API that's inside the cluster. Excellent. Let's keep on going. And you've got this output that also comes with a little, because you're using a Docker driver on Darwin, the terminal needs to be open to run it. And this is basically just a little warning that you must actually still have this terminal continuing to run, and we cannot close this terminal window. In the meantime, let's actually break down what this URL means. So 127.0.0.1 is basically just pointing to your local computer, so localhost. And then this 60473 is a port number that Minikube has picked to connect you to your service. So the number will be different every time you run this command, but that's okay. Just use whatever URL Minikube gives you. Okay, so now when you ask a question to your API, how will the requests get to the right places? First, your curl command will send a post request to the node port URL, this one over here, and then Minikube's node port will receive that request on port. So Minikube's node port receives that request on the port that's 3xxxx, so in our case it's 31180. And then Kubernetes service, the RAG app service, routes that request to a pod with the label RAG API that we've defined here. And then the pod with the label RAG API will receive that request and forward it to the container on port 8000. And then your RAG API will process the request before that response travels all the way back through the same path back to you in your terminal. And throughout this process, Kubernetes is going to be managing your container. If it crashes, it's technically managing your pod. If the pod crashes, Kubernetes will automatically restart it. If you scale to multiple replicas of the same pod, the service will know how to load balance between them so that not a single pod is overwhelmed. Okay, so the request flow will start from my computer to the node port URL, which is port 31180 for me. Then to the Kubernetes service, which routes the request to a pod with label RAG API. Into the pod. The service routed traffic by selecting the pod with label RAG API, and I think I'm happy with the response here. Awesome, so let's just select done on that and move on to testing the API. So let's test that the API is working. Since your first terminal is keeping the Minikube tunnel open, let's open a new terminal window where we will actually test the API. Let's select that new terminal button here. Awesome. And a new terminal will open up beneath your existing terminal. If you're wondering why I don't have this like side window here, it's because I've decided to hide my tabs, but you can always click show tabs to see them. I'll just keep them hidden. Oh, actually, I don't mind showing them to make it less confusing. Okay, and replace your API URL in the command below with your actual URL from the previous step. So here, let's actually replace this with this URL. And then we're going to run this command and press enter. All right, so this command will send the HTTP request to your RAG API in Kubernetes. So curl makes that HTTP request. Xpost specifies that this is a post request, and /query is the endpoint where your API actually accepts questions. So this is where our API accepts questions /query. And then -g converts the post to a GET request with the query parameters, where data URL encode safely encodes your question as a URL parameter. What is Kubernetes? I think all of this is a little bit technical, but I think the most important part is that you've got an intention. Hey, I'm going to post a question, and the response I want to get back, and my question is, what is Kubernetes? And I'm sending that question over to my API through this URL, okay, that I generated with my Minikube service. and I'm specifically looking for the /query endpoint of my API so that it can intake this question and actually generate a response. So as we can see in the response, we've got a JSON response, which is awesome. It tells us that our API is running in Kubernetes. That's huge. I know our response is kind of funny because it says pronounced Kubernetes. It didn't fully get to Kubernetes, but I'd say the definition itself is beautiful. It's perfect. So we'll still take it as a win. All right. So you've just deployed a containerized app to Kubernetes, tested it through a service, and got AI-generated responses back. Here we go. Kubernetes handles networking, routing, and container management automatically, so all the complexity is abstracted away, and you can focus on developing your application. Let's take a screenshot of your API working in Kubernetes. Beautiful. Put that in your documentation. And what did you observe when you tested your API in Kubernetes? We tested our API by running the curl command, curl-x post, and here is the entire command. The response showed a generated response explaining what is Kubernetes. This confirms that our API still works even when it's been containerized and is now running in a Kubernetes cluster. Beautiful. The main difference between Docker and Kubernetes deployment is that Docker equals running on a container, while Kubernetes equals running in a cluster where container management is handled for us. Great. And that is our task complete. Very nice. Great. That looks awesome. So let us, now that we've finished step 6, let us scroll down to see our secret mission for this project. Now, this secret mission is awesome. We are going to watch Kubernetes superpower, which is self-healing in action. See what happens when you delete your pod and watch Kubernetes automatically bring it back. And we talked about this a little bit earlier. We talked about how deployments are responsible for maintaining the ideal state for your Kubernetes cluster. So what's going to happen if you actually delete a pod? Now we know that for our deployment, the ideal state is that there is always one pod that is running the app. So if we delete that pod, Kubernetes is going to scramble to generate a new pod to make sure that that ideal state is always maintained. So let's see that happen in action with our secret mission. Okay, so in this project extension, we're demonstrating Kubernetes self-healing abilities. Self-healing is important because I would say it ensures that our app stays running. In other words, high availability. Even if a pod, i.e. a group of containers, is unhealthy or no longer running, Kubernetes can replace it with a healthy pod so that incoming traffic can still get their request served. In other words, users get uninterrupted service. Nice. Okay, so we'll start the secret mission by just checking our running pod. Let's run this command to see our pod. kubectl get pods reviews that we've got. I think this is okay. kubectl get pods reveals that we've got a pod here. Nice. Okay, and we can see that we've got our pod here. Perfect. And then we're gonna now watch self-healing in real time. Now for the dramatic moment, we're gonna delete this pod and watch Kubernetes try bring it back. So first, let's set up a live feed of our pod's activity. We're gonna open a new terminal window and then run this command and press enter. So kubectl get pods watch. You should see your pod listed and running like this. And that watch flag is basically the difference between this command and the previous one. You might notice that in the previous one, we just wrote kubectl get watch, but kubectl get pods, but adding watch means that you're gonna see the changing statuses that our pods are gonna go through. So we're gonna see that live feed of our pod status. Okay, now switch back to your original terminal window. And here we're going to actually delete our pod. We're going to copy our pod name from earlier. Okay, copy the entire pod name. And then we're going to delete your pod, replace your pod name with your actual pod name. And then copy this command, paste that here. And you can see that the pod has been deleted from our default namespace. Now let's immediately go check our other terminal window, and ta-da! You're going to see that our pod goes through a transition. The moment we delete that pod, the status goes from running to terminating. And then here, look at that, you already see a new pod with a new ID. It goes from R4KXQ to 8QD8X. There's a new pod getting created now. It's going pending, it's getting created, and then it's now running. So on the other end, you can see it's go terminating and then completed, which means it's completed its entire run. It's like a dead pod now. So the old pod has finished shutting down, but the new pod is now running. Pretty exciting. So you can press Control-C in this watch terminal to stop watching. Okay, but what happened is the moment Kubernetes detected that a pod was deleted, it immediately just started creating a replacement. Because your deployment says replicas 1, Kubernetes will always try to maintain that desired state. If you have 0 pods, but you've already told Kubernetes that the desired state has 1, Kubernetes will create 1. This is the reconciliation loop in action, which means Kubernetes is constantly comparing your desired state and its actual state, and if they don't match, Kubernetes will take action to fix it and close the gap. So let's upload a screenshot of the watch output showing self-healing. So let's take a screenshot of this. Beautiful. Put that in your documentation. And what did you observe when you deleted the pod? When we deleted the pod, we saw the status change from running to terminating to completed. A new pod was created because Kubernetes was comparing its desired state with its actual state, i.e. the reconciliation loop, and tried to close the gap by creating a new pod so that the desired state is reached. Beautiful. All done. So look at the pod name in your terminal output. Notice that it's changed. For myself, it's gone from something starting with R4 to a name starting with 8Q. Okay, so here's the critical question. So did your API actually go down while the pod was being replaced? How do we actually know if our API is still running? Technically, it is great that a new pod was created, but what's most important is that our service is continuing to work. So let's find out and actually test our service. We're going to use we're again going to get our service URL using Minikube service rag app service URL like this. We're going to paste that over here, and that again creates a new service URL for us. And this is basically a new entry point for us to test our RAG API again. So we're going to test our API using that URL, that new one. Copy, paste it here. And again, you should see a successful response. Beautiful. So Kubernetes is a container orchestration platform, which tells us that the API is still working perfectly with the new pod. And at the end of the day, why does self-healing matter? It matters because it saves the day during hardware failure, memory leaks, bugs, scaling down. My goodness. So that's how Netflix, Spotify, and every major tech company keeps their apps running 24/7. They don't have people watching servers and manually restarting containers all the time because Kubernetes does a lot of that automatically. Cool. So take a screenshot of the successful curl response from your API after the pod was replaced. So let's take that screenshot here and let's put that in here. Okay, and our question is, how did the service know about the new pod? So the service automatically cool. So the service automatically would have routed traffic to the new pod because, as you can see, I was hoping that we could see what labels these were tagged with, but technically we just look for, the service is always just looking for whatever pods have the tag RAG API. So we can just say, because the new pod would have been created with the label RAG API, which is a selector the service uses to connect to the new pod. Without Kubernetes, this would have without Kubernetes, deleting this running container would have caused the entire RAG API to stop working. Self-healing is critical in production because it saves the day when there's a hardware failure or memory leaks. In other words, a container crashes. So it saves the day when there are events like server crashes or memory leaks. I think hardware failures is the better word for it, i.e. events that cause containers to crash. New pods, containers automatically getting created to run the RAG API ensures that production systems or actually just run the app, ensures that production systems like Netflix and Spotify are always providing a smooth experience. Awesome. So, well done. You've just witnessed Kubernetes self-healing in action. This is how production teams keep applications running. Kubernetes automatically maintains your desired state, which is to have one replica, even when pods crash or are deleted. And this project is project 3 of a 4-part DevOps and AI series. It is totally your choice if you'd like to delete these resources or just keep them so that you can carry on to the next part. So here, let's wrap up with a few reflection questions, and then that's it for today's project. Okay, so key concepts we learned. So many new concepts today include Kubernetes, Minikube, clusters, deployments, services. There are also, I will say, node ports, and also self-healing. This project took us approximately 2 hours to complete. And the most challenging part is, and always is for me, understanding all the components that makes the service work. For example, node ports. It was most rewarding though to see self-healing in action, i.e. see the Kubernetes cluster generate a new pod when I manually deleted one. Awesome. We did this project because we wanted to learn Kubernetes and gain some hands-on experience. One thing we'll apply from this is how to run and access containerized applications that are running in Kubernetes clusters, i.e. using deployments and services. Beautiful. Okay, so you've just deployed your containerized RAG API to Kubernetes. You've learned how to set up that local Kubernetes cluster with Minikube. You've learned how to create Kubernetes deployments to orchestrate containers. You've learned how to create Kubernetes services for stable networking and how to deploy and access your containerized app in Kubernetes. So well done, wonderful work. You're definitely welcome to quiz yourself again. You're probably gonna see a beautiful spike in the score that you get if you've been able to follow along and do everything hands-on and slow down to learn the concepts and also fill out those tasks. So what a wonderful learning journey with you today. Next up, we're gonna be just automating deployments with GitHub Actions. So when your knowledge base changes, how do you rebuild and redeploy automatically? That's what Project 4 is going to do for us. We're going to add a CI/CD pipeline to automate the entire build and test and deploy workflow. Okay, mission accomplished. Phew! Beautiful. So let's download our documentation. You can open it up over here. So as you can see, all of our screenshots and our responses are collated here now. And you can actually just share everything on LinkedIn as well. We've already created the LinkedIn post for you. All you gotta do is click post. So I hope you enjoyed today's project. I hope to see you in the next part. Please feel free to share all of your feedback and all of your ideas or requests in YouTube. We hope to see you in the next week community too. And in the meantime, happy learning, everyone. See ya.